Now in part C, we're asked to find the probability that our rod was produced by machine C given that it was defective. So in other words, we're asked to find the probability it came from machine C given that the rod was defective. Now this is a typical question on conditional probability, which you've got to be so careful over the notation. Now, how do we work this out? Well, I'd like to think that you know this particular formula. The probability of something happening given that something else has already occurred. It is equal to the probability that both events occur, A and B in this case, divided by the probability of the given event, B. Alright? Sometimes this is written for short as the probability of A and B, often pronounced the intersection. The probability of A and B divided by the probability of the given event B. And this is a formula which I've demonstrated how it was derived in one of my tutorials on probability. So just go on to the tutorials on probability and you should find how this, as I say, is derived. Now then, so if we use this formula, okay, the A is the C and the B corresponds to the D here. So working that out then, we would have this is equal to the probability that both events occur, that is C and D. So I'm going to write that as C and D, okay, divided by the probability of the given event, which is D in this particular example. Okay, so we won't need this anymore, so I'll just remove that. Okay, and so the probability that it was produced by machine C and was defective was to come down through here and along this branch. In other words, 0.40 times 0.05. So 0.40 multiplied by 0.05. And the probability of being defective, well, because we used the correct notation, remember earlier I was saying that don't write any of these branches through here as being just simply PD, otherwise it's going to lead to a lot of confusion. Let's rub that out. Okay, remember PD was the probability the rod was defective. It could have come from A, B or C. Well, we've got the answer here anyway. The probability then of being defective is 0.0455. 0.0455. So all you've got to do then is just work this out on the calculator. As an exact fraction, it comes out at 40/91. But if you work it out as a decimal, you'll find that you get the decimal 0.43956 and so on, which rounded, say, to 4 decimal places is 0.4396 to 4 dp. Okay, so I hope that you've understood now how to do an example like this involving conditional probabilities, and that you realize throughout this question that you've just got to be so careful, so accurate in your notation that you use. Okay, well that brings us now to the end of question 2.